computer. Okay, excellent. I mean, excellent. I have some ideas. So let's see. One thingy. Close and share. All right. Okay, so let's talk about these practicalities, so to speak. I need to do that more. There's another thing that I need to bring your attention to that has to do with your accumulation of points for participation. So I have a bunch of people who I am very happy with. You guys, Jeremiah, Thomas, Eileen, Vanessa, Victoria, Rita, Norma, Jasmine, Kim, Sadiru, Elizabeth. Oh, Seaver, I left you out, of course. Jenny and Seaver, sorry.
No problem. A verbal acknowledgement
Sorry,
accepted.
yeah,
No problem.
I was doing it alphabetically, so I must have missed you in the process. You're good.
Yeah, no problem.
Good.
Sweet.
And then I have a bunch of people who are doing okay, which means they have something. It's Louis, Chidima, Terrence, Romain, Edgar, and Joanna. If your name is not listed, that means I have nothing for you. Now, know that we are almost at midpoint. Next week is going to be midterm. That is half of the semester behind us, half of the semester before us. You will only have the remaining 6 to 7 weeks to accumulate these points. Remember, you can only get 4 per week, so 6 times 4 is 24. That's it. You will never get 50. And if you don't start doing it at all, you may not get any. So I urge you, if you see the name, if you don't see the name of your partner, but you are one of the people who are doing great, okay, talk to them, convince them that they need to do more stuff. So again, I have another idea that I would like to implement to help you do some work outside of class. I know it's difficult, but from chapter 6, which is next week, anything that is listed in the learning activities at the end of the chapter. So let's see, chapter 6, where is it? It's chapter 6. This is page 179 of the textbook. I'm just going to show it to you sort of visually. Oops, too far. And then you can see that there is these learning activities. So in this case, there is 1, 2, 3. So do any one of them in your discussion forum. I mean, remember our forums are per week. So the forum for this week, which is week 6, is open. I also have posted, I think, 4 things for you because I see that quite a few of you are very reluctant to do anything on your own, which is too bad because it's actually your learning. But from now on, in all the remaining chapters, any learning activity at the end of the chapter is eligible for you. So all you have to do is create your thread in discussions on the Blackboard, name the activity or page whatever, activity number 1, so you don't have to retype the questions, and I will credit that as your participation. I will continue to beat the dead horse by saying that if you don't do things outside of class, no amount of listening and even doing exercises will help you learn. The only way to learn is to do things. So that's my piece of wisdom to you guys, and especially in this class, because this is a skills class. It's not, I mean, I do talk about things, but really, I really need you to be involved with the material. If you're having issues with the scales, you need to practice. And that's what we will do today. Okay? And I will continue to ask you to, if you are present at the lecture like today, write a 200 word or more summary with maybe some questions. That will count as a point. I also posted CSI Department of Psychology colloquium. A colloquium is an event when somebody is presenting something and then people participate in a discussion, which will happen this coming Tuesday, the 13th. That is a week from today, between 2:30 and 3:30. That's the club hours. It's of course on Zoom, and it's dedicated to psychological research at our department. So there you'll meet. It will be uh, sort of directed by two of my colleagues, Dr. Sarah Berger and Dr. Kristen Gillespie Lynch. Dr. Berger is a specialist, a well known specialist in infant motor development. So, if you have ever wondered how little babies crawl and cruise and then start to walk, and why is it it's so important for them to nap, because that's where consolidation of motor skills happens, then Sarah's lab, Dr. Berger's lab, is excellent. And she has a lot of stuff that she can do with her students online. Of course, the actual data collection is always in. We have a beautiful infant lab on the second floor of Building 4S. So, and the second person is Dr. Gillespie Lynch, and she is one of the leading experts in autism. And she has a program called Reach, I think. Maybe, no, I think it's Reach, where students help other students who have developmental disabilities, but they're not children anymore. So if somebody has and what we used to call Asperger's, or maybe high functioning autism, these students continue into college and they have very little support. So Dr. Gillespie Lynch's program pairs mentors from the student population with these um, students, and they help each other. You can learn a lot from somebody who has a very different perspective on the world. And obviously, you help them to do better in school. So, and these are just two representatives, and there will be, I think, two or three current students who work in these two labs who will participate and describe the experience. Again, I want to remind you that when you get to your senior year, if your GPA in psychology, not your general GPA, is 3.5, you're eligible to graduate with honors from our department. And to do so, you need to put in 2 semesters of independent studies where you would create your own study and write your own honors thesis. And this class is an excellent preparation for that, if, of course, you decide that you wanted to do that. But students often don't know that we have so many labs and so many different faculty who are uh, quite well known. So if you attend this event, the information is posted for you both in the announcements and in the activities for this week 6. So that so with the other stuff, there's already 4 things that you can do. Okay, so here's the bad news, right? This is the range. That means that the highest score was 9, the lowest score was 2, and the mean, 4.7. That is not even a D, that's an F. So I find it depressing. Not that it's anything new, it happened before. Chapter 5 is difficult because chapter 5 is foundational. If you still cannot do anything with variables, your goose is cooked. Doing psychology is not going to be in the cards for you. And if you didn't spend enough time or it wasn't very clear to you, that's the result. Now, of course, a bunch of people said that the time management was a problem. So to accommodate this for the remaining 3 tests, I will add 15 minutes to them. So your quiz 3, which is due 2 weeks from now, on October 21st, I believe, is going to be 45 minutes. And quiz 4 and quiz 5 will also be 45 minutes. But the structure will remain the same. There will be 8 multiple choice questions and 2 short answers. Of course, Blackboard randomizes the presentation. So you may be the unlucky one who gets these questions in the beginning, or maybe even worse at the end. So you have to be prepared. That's why you have to read the chapter. And we will try to talk a little bit about strategies today because I actually do that. I'm a cognitive psychologist. So I hope that's something that you are willing to accommodate. That is, the syllabus says 30 minutes, but it's going to be 45 to help you have more time to deal with short answer questions. Unfortunately, I have to say, because I was grading yesterday, that the answers were pretty bad, which tells me that I need to spend more time with you guys today and probably on Thursday talking about the test. Okay, Jeremiah gives me a little emoticon. Okay, good. All right. So any other, wishes or accommodations or something? Remember, we are partners in this. I understand it's kind of hard to think of me as your partner, but I am. I have no desire, nor any of my colleagues, to ever fail a student. Students usually fail themselves. And if you have issues or problems, even if you think that the question is kind of stupid or silly, there is no such thing. The silly thing is not to ask. I'm here for you. So that's the idea. Okay, so let's see what we will try. I hope we can get through 1 and 2 today. So talk about research design and variables and scales, and then do the reliability. That's the easiest stuff. The validity is the hardest part, and that I will probably have to talk to you about on Thursday, which is a mandatory class for everybody to attend. This one, as always, is optional. So thank you guys for being here. This is for you. Let's pull our favorite flow chart that I hope you have close by because it is important. Let me do it again, that this flow chart is basically the skeleton of the class. So if you progress through the flow chart, you are progressing in the class. You hopefully are learning what you need to know to continue to become producers of psychological research as opposed to just being educated consumers. So before I show you the next slide, can somebody say, or type if you prefer, what's going to be in the next blank rectangle below generate a hypothesis?
Is it experiment?
Okay, Rita, well, but before the experiment, right, what do we need? What are the components of any claim that we have to have? Without that component or two, there is no claim.
Variables?
Yes, thank you, Rita. Exactly. We need variables, and variables are defined and identified in the section of research process called design. All right, so here we are. Our next stage here is designing a study. And when I say designing the study, it's all these 4 things that are listed on the right. So I hope you are making notes in your flow chart, right? We have to define our variables using the knowledge of concepts and conceptual definitions, moving to the operational definitions of these variables, defining them in terms of the kinds of operationalization that is being used for them. That was one of the problems that I've seen in your answers to the two short answer questions. People kept saying it's an observational variable. That wasn't the question. Then you have to choose a method. So what's going to happen with chapters 6 to a certain degree, 7, we are not doing chapter 8 at all. And chapter 9, so 6 through 9, we will be talking about methods. Now, there are many methods in psychology. We will only talk about really 3. We will talk about surveys. That's coming up next week. And chapter 7 is also related to that. That's about sampling. Then we will also do observations, which is the second half of chapter 6. And we will move on in November to experiment. So Rita is correct in the sense saying, yes, this is about not experiment, but this is about a method, because out of these 3, observation, survey, and experiment, only the experiment is the experiment. We often use the word experiment as sort of a layman way of saying we will test something, right? But because you guys are psychologists, you have to be very careful. Nothing is experiment unless it's a causal claim that meets all 3 of the characteristics. And here is, thank you, Jenny, maybe theory as well. And here is my chance to torture somebody. Louis, are you with us? Okay. Kim, how about you? Do you remember the first criterion for causation, for causal claims?
Um, I don't. I'm sorry.
Okay. Remember, I asked you guys to memorize that. Vanessa, do you remember the first criterion for causal claims? Huh? Something happened to Vanessa. Okay. Oh, no, there she is. Okay, Vanessa. So what's the first criterion? Guys, if we continue to not remember things like this, you'd have to repeat the course. The first covariation, thank you, Louis. Yes, excellent. Who can do the second criterion? I am not even going to ask somebody by name. Volunteer quickly because we are running out of time. Temporal precedence, thank you, Jenny. And who gets the third one?
Internal validity?
Internal validity, thank you, thank you. Rita, you have a question or you're okay?
No, I wanted to tell that. That's why I
Ah,
just
okay,
wanted.
you wanted to answer the question. Okay, goody.
Yeah.
Perfect. Yes, so covariance or covariation, the 2 variables covary, one precedes the other, and there is no third variable that intervenes between the one we manipulate and the one we measure. So for experiment, we have to have a manipulated independent variable and measured dependent variable. Everything else is not an experiment. It's a study, a correlational study, an observational study, whatever that is. And today we'll talk about variables and measurements, and we will move on to methods next week. Okay. All right. So conceptual variables, we talked about them before in chapter 2. Conceptual variables are not very useful. They're fine to talk about at the dinner table, but they're not good for any kind of science because we don't know if it's a conceptual variable of happiness. We had this example many times, or a conceptual variable of love. We don't know what it is unless we come up with an operational definition, unless we operationalize them somehow. Okay? So, and that's what is presented to you in the textbook as 3 types. So another example that I want to use is the example of intelligence. So can somebody tell us what you think the conceptual definition of intelligence is. Who is an intelligent person? What makes somebody intelligent? Again, you can either talk or you can type, whatever you want to do. But quickly, let me see if you can think on your feet. How high your IQ is. Okay, all right. That would be a nice operational definition. But before we even get into the operational definition, Louis, who do you consider an intelligent person?
Someone who knows how to apply knowledge.
Okay, somebody who has a lot of knowledge and knows how to apply it, which is education. Logic, Vanessa says, perhaps. Kim, knowledge. How about somebody who can quickly solve, flexible in their thinking? Yes, Victoria, perfect. All these things and more, of course, would give us the conceptual definition of intelligence. So here is the official one. It's the mental ability, right? In our head, we can reason, we can plan, we can solve problems, right? We can think abstractly, we can comprehend complex ideas, and we can learn quickly. All of these things, and we can learn from experience. All of these things combined define intelligence. And then Lewis is right. We can use what we already have as a way of coming up with an operational definition. So, for example, because IQ scales, and we have two major ones. There is WISC and there is Wechsler. They all contain subtests, that is, more than one thing. So, for example, imagine that you're a child. Of course, you guys are all adults. One of the questions on the Wechsler intelligence test for children is, what is the meaning of derogatory? Does anybody know the answer to that question? Okay, well, imagine that you're a third grader and a person who is administering the test is asking you this question, and you only have a very limited amount of time of answering. You guys already blew your time. The next one is, why street numbers, why are they in order? Or how trees and plants are alike. All of these are questions that measure intelligence in children, or you can do a little bit of math. Yes, yes, Jeremiah. It just takes me a couple of days, but hopefully by Thursday I will have the recording. All right. So now, when we talk about the types of variables, we are talking about how we operationalize them. So an observation variable is not an observation variable per se. It's the way we are dealing with this variable. We are observing it. It has nothing to do with what this variable itself is. We are observing behavior, and behavior has to be operationally defined. So plain behavior that we can observe, children at the playground, students in class, customers in the grocery stores, all of these are human behaviors. Even attending a class is a human behavior. So it's not a type of variable, it's the type of how we would operationalize behavior in the store, or behavior on the playground, or behavior in the parking garage, or whatever else you may be interested in studying. So whenever you answered the observational variable or the question about scales, that was completely off from the question. The next one is self-report. Again, how do we operationalize? Let's say I don't want to administer an IQ test. I want to use an operational definition of self-report. So I'm going to ask my participants, do you think you are intelligent? And I could also ask them to either guess or report, if they've ever taken an IQ test, what the IQ score was. But they are telling me I have no way of, unless I test them, to find out whether the self-report is a good operational definition of intelligence. I mean, how many people will say, no, I'm not intelligent? Probably nobody, but we know that intelligence is normally distributed, right? Most of the people are at 100, although, like I said before, there's a Flint effect. It's more like 110. But that means that there's a bunch of people who are much more intelligent than that in the right tail of distribution. And then there's quite a lot of people in the left tail who are less intelligent than that, but nobody will ever admit to that, right? So self-report is an operational definition of people telling us themselves what they think about intelligence. And the last one is physiological, where we actually get to record biological or physiological data. So we can record people's brain activity if we are using neuroimaging. We can record people's galvanic skin responses. This is how polygraph works. We can record people's breathing. Think about the stress test when you are going to your cardiologist, stuff like that. So these are not variables. These are types of behavior, okay, that allow us to operationalize them in different ways. So if we take the intelligence again as my example, self-report would be people saying, I'm intelligent, and maybe I'm 100. Observational would be to give them some kind of a problem, maybe crossword or Sudoku or anything that requires intelligence, and see how they do. And physiological would be to hook them up to some kind of a fMRI and see what goes on in the mind, in the brain, when they're solving particular problems. So exactly the same idea can be tested for the operationalization in 3 different ways. Okay. So again, I've seen at least half of people saying observational variable in answering that one of the questions. We'll get to that question soon. Yeah, I'm not showing you any of that just because there's so much stuff on the web. If you have time, you can check out neuroscience and see what happens in the brain, regardless of intelligence. Okay, so here's my first question to you guys. I hope you have your notebooks ready. We're not going to go to Google Docs just because it takes so much time. So just have your notebooks ready and answer questions in the notebook. And then in a minute, I'll ask one of you to report to us. So here's the question. It's not from the quiz. It's just another question. Serena plans to interview several teachers about the attitude toward teaching children who have attention deficit hyperactivity disorder for her research methods class. This is an example of what type of operationalization. And we just talked about 3 of them, right? So, okay, let's do the following. Raise your hand if you're ready to answer that question. Volunteer. Yes, very nice. Okay, Seaver, let's take it and run with it.
Okay. So if the student is asking the teacher, it's definitely not self-report. I was between observational and physiological. It's because the recording of biological data, I'm just, maybe I'm getting too in my head because ADHD, is kind of biological. So maybe I'm just kind of making a weird association, but I'll say I raised my hand thinking observational opera operalization.
Operationalization. I know I'm struggling with this word.
Operationalization.
Right.
Yeah, geez. Yeah.
Okay, so your choice is observational, right? So
Correct.
you're
I'm
just
going with that.
Just think about it for a second. How would you observe
Mm.
teachers? Look what she's doing. She's doing an interview. What happens in an interview?
If you're observing teachers,
No, that's what you said, but I'm now asking you a different question. I'm asking you, read the question. The question is about interview. What happens during the interviews? There is a person who asks the questions, and then there is a person who answers these questions. And when you answer the question, what happens? You are reporting your own perception of the topic, right?
Gotcha.
So
so the teachers are reporting on the behalf of the students. That's
right. They are the ones who are thinking about how they would teach these guys. Sadiro, do you have something else to add to our little discussion?
Yeah, no, I was just gonna ask if it was what is self-report, because it's based on the teacher's opinion.
Yes, absolutely. Whenever you get your participants to say something about their attitudes, it is going to be self-report. Okay, goody. Thank you, Sadira. Perfect. Thank you, Seaver, for thinking out loud. All right, so let's move on to the real stuff. Now, I've been talking about many times, but let me repeat it again. So we have two types of variables that we care about. In experiments, they are called dependent and independent variables. In non-experimental studies, correlational, observations, surveys, they're called predict and response variables. Now here I'm listing them in pairs, so it sort of sinks in your head. So if you're looking at the association claim, one of the variables is going to be a predictor variable. If you're looking at the experiment, the one that you manipulate will be the independent variable. The second one will be a response variable, and both of them, predict and response, in association claims are measured. And in the experiment, it's going to be a dependent variable, which will also be measured. So predictor response, measured, independent, manipulated, measured. And that's our third criterion of causality. Now, for every variable, whether it is predictor, independent, response dependent, we have to answer the question, the type of this variable, that is, what does it consist of? Is it categorical or quantitative or continuous? Okay, so categorical is a large general class of variables, and it's all about quality. And quantitative or continuous are numbers. If you can remember these two things, category, name, continuous, number, you are already in business. It's halfway of answering a bunch of the questions from your quiz too correctly. There's a little bit of an issue with the textbook, and I'll talk about it in a second, the way Morling talks about ordinal scales, which I disagree. But as long as you understand, you'll be okay. So categorical variables are names. The levels are categories. We've done that before, but let's do it again. Hair color is a categorical variable. It's about quality. Are you blonde? Are you, red-haired? Are you brunette? Are you whatever? If it is about your college standing, are you freshman? Are you sophomore? Are you junior? Are you senior? These are names. Names, nothing else. And the levels are categories. So there's a category of blonde people and category of brunette people and category of freshmen and category of seniors. Names, 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 names. Categories are names. And we measure categorical variables on two scales. And this is where I disagree with Morling. So the first one is easy. It's nominal scales for names that are not ordered in any meaningful way. There is no, one could impose some scientific thinking, but there is no meaningful way of saying brunette, black hair, red hair, blonde are arranged in sort of stepwise fashion. So that's going to be a nominal scale. Nominal scale, names. Ordinal scales in Morling's textbook are used to do continuous variables. That's not right, again, in my opinion. It's also names, but these are names that are organized in order, right? Usually it's words like first, second, third, last. In terms of statistics between these two scales, and that's why we need to know them, because the scale tells us which statistical analysis to use. In terms of statistics, these two do not differ. You might as well say they all are categorical or qualitative, and it's going to be the same statistical analysis. There will be some little variation, but not much. So these are names versus continuous variables that are numbers. So categorical, names, continuous, numbers. There's one little twist that sometimes we use numbers as names. That's a little confusing, but as long as you understand that one could mean just one and not be one on the number scale, you're okay. So we can use the names of digits as our categories, as our names. So continuous variables are the ones that are numbers. Think about a number scale from your 6th grade math in junior high. We have, let's say, 0 to 1 or 0 to 100. A number is placed somewhere, and there is no number that's too small. It's infinite. That's the beauty of continuous scales. They are continuous numbers. So names versus numbers. And for the purposes of, again, statistics, we have two scales that measure continuous variables. One is called interval, the other one is called ratio. Again, for the purposes of statistical analysis, these two scales are the same. What's different is you have the equal intervals because the difference between 1 and 2 is the same as the difference between 2 and 3, or between 13 and 14, or between 500 and 501. That distance is the same, and that's critical. And there's also no true zero. And true zero means it's a difficult concept, but not so difficult that you not to understand that. That means that whatever that is, it doesn't exist. Usually, think about it, we don't have true zeros on scales or instruments that we humans invented. If it is something that's of the physical world, then there could be an absolute zero. It just doesn't exist. I know it's a little too abstract, but we'll get to some examples, and hopefully that will become more comprehensive or comprehensible, I should say. So categorical, nominal, ordinal, continuous, interval, ratio, categorical on names, continuous on numbers. All right, let's now play with some examples and see if that sinks in. So whenever you are presented with a question about variables, and that's going to be your first step for assignment 2, we'll talk about it on Thursday, is to come up with your variables, with your claim. And then you have to go through this exercise of saying, well, I have an association claim, and that's what you will be testing, an association claim. I have one variable that's predictor, another variable that's response. For each of them, I have to answer these questions. Is my predictor variable categorical? Or is it continuous? Is my response variable categorical? Or is it continuous? If you answered yes to the categorical question, then it's easy. You just have to name. And I could say, okay, in my class, I have 35 students, and their names are Vanessa, Victoria, Rita, Seaver, Thomas, and so on. These are names. I just name them, okay? If it's continuous, then I can't really list everything. I mean, technically, I could look in my Excel sheet and say, this is what the city scores are. This is what the scores for quiz 2 are. But it's kind of stupid because you can't list infinite number of values, which is what happens with continuous variables. And now you would have to decide whether this is something that was invented by humans, it's a scale that was created by us, or whether it was something that existed in the physical world regardless of us, regardless of our scales. So let's do a little exercise. Let's look at the first one. So here we have an A, and it's degree of pupil dilation in a person's eye in a study of romantic couples. So what we want to do, we want to take this variable, degree of pupil dilation, and first decide, is this a categorical variable, names, or is it a continuous variable, numbers? Who can answer this question? Degree of pupil dilation. Well, tell me if you don't understand what, oh, good, Kim says continuous. Why, Kim? You are correct. Which is the keyword that tells us that this is a continuous variable? Degrees, that's right. And degrees are measured from 0 to, what's the upper limit? 360, yes. So these are numbers, right? This is a continuous variable because you can have 1 degree of pupil dilation. That's a little funny. You can have 90 degrees of pupil dilation and so on. Whatever. So now, having identified that this is continuous, we have to say, is this measured on the interval scale or is it measured on the ratio scale? Now remember, pupils are something that was given to us by Mother Nature, God, whatever your choice of creation is. Is it a physical object that exists sort of without our will, or is it something that we have invented? If you take any other circular object, you will be measuring it in degrees. And if you're not a circular object, if you don't turn around, there will be no degrees, right? So this is the physical measurement that is not subject to our ways of measuring it. So this continuous variable will be measured on the ratio scale. Does that make sense, people? All right, let's do B. Who can tell me number of books? Is it the categorical or continuous? Good, good guys, continuous. What are the possible answers? Well, 0. In fact, you'd be surprised that I forgot what the number was. Somewhere between 30 and 40% of American households do not have a single book in their possession. And other people may have, I have a lot of books in my house. Well, because that's what I have to do. So it is continuous, very good. Now the question is, can you measure it? Should you measure it on the interval or ratio scale? Again, the absolute 0. And I just gave you an example. Households that don't have a single book in the house have an absolute 0, right? So the scale is going to be, which one? Thank you. Ratio. Perfect. All right. I'm going to give you 5 minutes to do C, D, E, and F. And it's 5:25, so at 5:30, we will finish that, maybe have a 5-minute break and move on to couple of questions from your quiz. If you can do it faster than 5 minutes, even better, raise your hand. So we're doing C, D, E, and F. You're identifying whether the variable is categorical or continuous, and which of the four scales it is measured on. Okay, well, it's 4 minutes. That's all right. Who can do C? I need two words from you: categorical or continuous, and the scale. And we need to do it quickly. And I would like to hear somebody else who hasn't done anything yet. You can
Oh, is it
go.
okay?
Yeah, go ahead, Sidiro.
Um, I'm not sure, but I would say continuous because uh, well, I mean there is a true zero, but you don't know how much it will go up, like how many sales a book will have.
Now, but think about it, Sidiro, for a second.
Mhm.
This is where the sales are ordered, right? There is a book that's number
Okay.
one sale. There is a book that's number 200 sale.
Oh! I thought you meant like as in how many of the book is sold.
No. It's the actual rank. See the word rank?
Oh, the rank.
Rank
Oh, then
is a keyword. So which one is that?
that would be categorical.
And what would be the scale?
It would be ratio, right? Because there would be a
No, remember, ratio scales are only for continuous variables. This is,
Oh, okay.
so which one is it?
Would it be interval?
Zero. Interval and ratio are only used with continuous variables. And this is a categorical one. First, second, 200, 1000s. It is an ordinal scale, right? These are the names:
Oh,
first book, 200th book, and they are ordered, right? The one
mhm.
that's being sold the best and the one that's being sold. So the correct
Oh,
answer
okay.
here is going to be categorical ordinal. All right, but a good attempt.
Okay.
Who can do D? Thomas, would you like to do D?
Um, okay, I think this one is um, the categorical.
And correct. And what is the scale?
Uh, it's It's nominal.
Yeah, ding, 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 ding. Correct, Thomas. It's a categorical, and urban, suburban, there's no way we can order that in any meaningful way. So it's a plain nominal scale. Fantastic. Good job, Thomas. Who can do E? Romain, would you like to try to do E? Oh, somebody else? Yes. Who is volunteering?
Me.
Vanessa. Perfect. Vanessa, go ahead.
Would it be categorical and nominal too?
Exactly, because we can't order Canadian, Ghanaians, and French students in any meaningful way. Good job, Vanessa. Perfect. And the last person who is willing to do F.
Got the last one?
Romain, go ahead.
I said it was continuous. Because it's a student grade, and from that I know it is.
Romain, just think about it for a second. What are the grades the students get? They are.
The what?
What are the grades that students get? They are A, B, C, D, or F, right? Are these numbers, Romain? What do you think? Are these numbers? A, B, C, D, and F. The GPA is number. These are letters. If these are letters, they're not numbers, right? And if they're not numbers, they are
categorical.
Very good. And if they're categorical, now you have to answer the question whether this is a nominal scale or ordinal scale. What do you think? Is A higher than B? Is B higher than C? Is C higher than D?
Ordinal scale, because it's ranked in like a certain order.
Yeah, so which would be the scale?
Ordinal.
Fantastic. Good job, Romain. Perfect. Thank you. Let's move on. Oh, we can't move on now. We will. Let's do a couple of questions and then have a short break. So Hannah is studying the relationship between caffeine consumption and problem-solving ability. So what would be a categorical way to operationalize caffeine consumption? And which scale should it be measured with? So remember, categorical variable is a variable that has names as its levels. So how can you come up with a categorical definition of caffeine consumption? Okay, remember, these are names. Let's say you are not a coffee drinker at all. So what's your caffeine consumption? Do you consume caffeine at all? No, the answer is Vanessa.
No, not continuous, is it?
No, it has to be categorical, so it has to be names. So what would be one caffeine consumption level?
0.
Right. Do you don't want to use a number because you get confused between numbers and names. Say no coffee, somebody who does not drink coffee at all. And what would be another way of the opposite value of no would be? Well, now you're consuming coffee, right?
Yeah, a casual coffee drinker, and then another one could be like a
a casual coffee drinker or extreme coffee drinker. So now you have 3 values. You have no coffee at all, casual, occasional, right? And expert, that you drink 4 cups a day or something. And what scale will you be measuring this variable on, Vanessa?
Would it be ratio?
Remember, ratio and interval scales are only for continuous variables, and this is a categorical one. So which of the 2 categorical scales can you use? Either nominal or...
Oh, ordinal, sorry.
Okay, if ordinal, yes, from the word order, right? You order things up. Very good. Thank you, Vanessa. We can quickly do now a continuous way to measure caffeine consumption. Victoria, go ahead.
Um, Hi, Professor. So I think it might be the numbers of cup of coffee consumed in a day. It might be
Uh-huh.
0, it might be 10. So in 0, it's maybe ratio. Yes?
Yes, it's going to be a ratio. If somebody doesn't drink coffee at all, consumed zero, it's an absolute zero. There is no coffee that this person drank. Perfect. Excellent job, Victoria. Now you guys, we're getting there. All right, it's 5:36. Let's have a tiny little break for 4 minutes until 5:40. And I'm here if you want to ask me anything else. So break until 5:40. Ooh, I have it in Russian.
Miss Sakarina, did you take attendance already?
Remember, Jasmine, that this is not a required session. So,
Oh no, because I had emailed you because I just finished a test. So I wanted
just
to make sure I didn't really miss out on a lot.
uh,
Yeah, I
you?
just took a test for another class.
Oh, so you came in late. Oh, okay, that's not a problem. Remember, this is not a required session, Jasmine. So you're good.
It took a little help on this side.
Okay. The problem
Thank you.
is that we have been discussing quiz two, which the scores are not so good. And yeah, I hope you will have time to maybe review this recording later. Okay, let's get to this. Yes, Vanessa, the whole idea is unfortunately that we are in a situation where you guys have to be the drivers of your own learning. And you need to learn to recognize whether you're doing a good job or not. And that's one of the reasons why you're taking the quizzes before we have a class. In fact, all of that is in the textbook, but the only difference is that ordinal scale in Beth Morling's interpretation measures quantitative variable, but that wasn't even an issue for vast majority of answers. The answers were just so wild that I was like, oh my God, what's going on with these students? Are they all zombies? Why are they doing this? So here is, I know we still, oh no, we are off. Okay, good. So here, a zombie question that is, this is one of your short answer questions from quiz 2. So let's read it carefully. In a study of aggression in children, a researcher has his undergraduate research assistants watch a group of children on the playground and record the number of instances of physical or verbal attacks. Classify this variable. So which variable are we talking about? Quickly. What is the variable here?
It's continuous.
Well, before you identify its type, name the variable.
Oh, okay. Aggression.
Now be careful, read it fully. Thomas, look. The number of instances of physical or verbal attacks. So the word number is in it, right?
Yes.
Which means you are right. What is this variable? Is it categorical or is it continuous?
It's continuous.
Very good, Thomas. That's absolutely correct. So what are the possible values? Of course, remember when it's a continuous variable, we can't name all of them. So what's the minimum of the number of instances?
So zero.
Zero.
Would be
If
the minimum.
that's right. If a child didn't do anything, it's zero, and maximum could be whatever, we don't know. So now we are saying, yes, it's continuous. Which of the four scales? It's not just a question to you, Thomas, it's a question to anybody. What would be the scale that we could use to measure the number of instances? It's just like the number of books in the house, right? No instances, zero, a bunch. Somebody quickly give us the scale.
Interval, right? Because there could be 0 cases of aggression.
Okay, Seaver, absolute zero. Which scale has an absolute zero? Interval or ratio?
Not. Oh, I'm sorry. Ratio.
You meant
has the true
ratio.
0.
That's
I
right.
meant ratio.
Very good.
With the true 0.
Yeah. So the answer here is it's continuous, and it should be measured on the ratio scale. And what would be examples? 0 number of instances, or 5, or 10. And I didn't get, I think maybe there's one person who did it okay. Not quite exactly correct, but a lot of people said observational variable. What is this, people? Look at this question. There is nothing about operational definitions in it. And the word number is in that question. So that is an example of you guys not quite understanding chapter 5, unfortunately. Okay, here is another one. This is a multiple choice question. Sasha wanted to know if there is an effect of popularity on academic success for her undergraduate thesis. To do this, she has elementary school students rate how popular each member of their class is. She then uses this information to rank the students on popularity. That is, Larry is the most popular, Melissa is the second most popular. Now, before we even look at the two questions, tell me in terms of the operationalization, which of the three types is this? Is it self-report? Is it observational, or is it physiological? See? Self-report, Vanessa, perfect. Yes, because these children tell us, oh, I have 200 friends on Facebook or whatever, TikTok, whatever the child is using. Now, let's quickly answer the questions. So, how she ranks the students on popularity. The most popular, the second most popular, the third most popular, and so on and so forth. Is it categorical or is it continuous? Note that she doesn't care about the actual numbers. She just takes children's names, right? Just like the sales rank on Amazon. The most popular book, the most popular student. Okay, I'm looking at the chat. Categorical. And Ordinal, yes, Seaver, perfect. That's your question from quiz number 2. Okay, that's another one. A short answer question. Let's quickly do that and move on to reliability. Ms. Morris is teaching children in the 2nd grade. She's planning on measuring literacy. It's an abstract concept, i.e. children's ability to read and write text in English. She decides to measure literacy in 3 ways. By creating operational definitions for this abstract concept, create an ordinal, interval, and ratio ways to measure literacy. So, what could be an ordinal way to measure children's literacy? Let's assume our class has 20 children. So remember, ordinal scale is about ranking. And in this case, we don't care how literacy is defined. We're just doing something to the students. Anybody? Joanna? Okay, somebody else? So if we take out 20 children, right? We're going to measure their literacy, whichever way she's going to do that. And then she's going to say, Larry is the most literate one in my class. And Jenny is the second most literate in my class. And Harry is the third. Right? So ordering these children in their ranks in terms of literacy will give us an ordinal scale by saying this is student number 1. Reading level, perhaps. It might be a problem, Vanessa, if we have to go into the numbers, right? This has to be ordinal. So maybe the best reader, the fastest reader, the second fastest reader, the third. Okay, who can do an interval, a variable for this example? IQ. Well, Vanessa, we're not interested in IQ. We're interested in literacy. So replace the IQ scale with vocabulary or literacy scale. Again, whatever the scale is, as long as we invented it, which means that if you have a 0 on literacy scale, it doesn't mean you're not literate. It just means that our scale does not measure it. Just like the 0 IQ doesn't mean no IQ. It means our scale cannot handle it. It's not a true 0. Okay? And the ratio way would be, is Vanessa the only one who's working with me and somebody else? Victoria, would you want to do the ratio way of measuring literacy in this example?
Maybe how many books do you read?
How many?
year?
Well, it's possible. For 2nd graders, it probably is not the right.
Oh yeah,
measure.
yeah.
So let's take speed. So if you give a child a short text, let's say 200 words, you can measure how fast they read it, right?
Yes. So maybe how long they take them to read 200 words.
For example, yes. And there we have a ratio scale because there are potentially children who can't read anything. So it's going to be 0 minutes for them. Okay, so this was your second short answer question from the test. I'm going to skip. Okay, we have another. Oh, we still have a little bit of time. Let's move on to the second component of chapter 5, which is reliability. That's not particularly difficult. So let's quickly talk about reliability and see what we can get out of this. Because our third part, so the first one was variables and scales. The second one is reliability, and the last one is validity. Validity is the one that we will get on to talk about on Thursday. So reliability is how stable or reproducible our measure, the way we measure our variable is, right? And validity has to do about how valid it is. Does it measure what it pertains to measure? So not validity for today, but just reliability. All right. So think about if you go to a Foot Locker, you're going to ask the salesperson to measure your feet. Hopefully, if you're going to get size 8 or size 10 or whatever your size might be, if you go to another store somewhere, Nike maybe, you're going to get the same size, because measuring feet is using this little metallic ruler of sorts is very reliable. It's the same metallic foot imprint that is used in every store across the country. In Europe, it's different, but they have their own measurement system. But if you try to measure something that is more nebulous, like Mozart effect, will your baby's IQ intelligence improve if you get your baby to listen to music by Mozart? You may not be able to replicate that. So there are two meanings of reliability, but we have this technical definition that comes from these three types of reliability. So we have test-retest reliability, we have internal reliability, internal consistency of reliability. That's the hardest one. And then we have the inter-rater reliability. So let's look at all three of them and then maybe do another little exercise or something. Okay, so the easiest way, if you take your instrument, and here's another little problem. The word scale that I've been using today means the way you measure variables, but the word scale is also used as a synonym of an instrument. You can say this person's score was measured on a depression scale. And that is a different way of thinking about scales, not the technical one that we have discussed. So test-retest procedure allows you to use the same scale or the same assessment or the same test, right? And then repeat it again at a different time. Usually we call it test-retest, meaning that there's going to be some time between the 2 points. And it's a very common device in program evaluation. So you can give your participants a test in the beginning of the program and the same one or a slightly different one at the end. So we often do that in our classes. When the semester starts, we give our participants a test of what they know about the subject. Then we teach them, right? We go through the semester doing all the activities that we do and do a retest at the end. And we assume that if our teaching and was successful and learning took place, people's scores on the retest or post-test, sometimes it's called, will be higher than on the original test. But if you are not looking at the changes created by the program, then just administering the same test should give you the same results. So somebody who scored high on the IQ test should also score high on application of IQ test sometime in the future. Personality, the big five, more or less also. But let's say a depression scale may not give you the same results because people certainly get out of depression. Okay? So if you are thinking, well, if I took this test today and somebody is going to give it to me a week from today, I will remember. At least I will remember that I saw these questions before. So to accommodate that, psychologists create what's known as alternative forms. So you have the same test, but you create two versions of the questions, or at least some versions of some questions. So you may get people the same questions, but not all of them. Again, for test retest reliability, you've got to get similar results. They're not going to be the same, completely the same, maybe just for the shoe sizes you might. And that's what is shown. Oops, I'm looking at chapter 6 in the textbook. In chapter 5, let me see which. Okay, so page 135, there is this table from an actual research meta-analysis study that shows how well the measures were replicated by somebody else. And there are plenty of examples of that in the textbook. Yes. All right, internal consistency. That's where you need sort of this knowledge of specific statistical techniques. But for the purposes of our class, all you need to know, you have to understand that if you run a particular scale and get the score, then you run it again and get a score. If you then use half of the questions from the first application and half of the questions from the second application, they've got to be consistent. It's often is the case when we create questions in such a way that some of them require always positive answers and some always require negative answers because the way these questions are designed. So a good example that we already discussed before is the Rosenberg self-esteem scale. So here you see 10 questions, and you can see that questions 3, 5, 8, 9, 10 have asterisks in front of them, which means that they have reversed wording. So you would get the answer on 1, 2, 4, 6, 7. 1, 2, 4, 6, 7, yes, 5. Where if people agree on them, they should disagree on 3, 5, 8, 9, and 10. So this is called a split. Let me go back. Called this split half reliability. Now, Rosenberg scale is very short, so it's kind of difficult. But for many long assessments like depression, BDI, that is discussed in the textbook, that is used a lot. So the problem is that, and we will talk about it next week, is that when people do scales, you see the word scale here, right? When people do assessments, they often are trying to figure out what the researcher is asking them and trying to play either by helping the researchers or not helping them, right? So when we create this internal reliability, we also want to make sure that our participants are not playing dirty games with us. We want to catch those who are just going like this. And I'm sure you have done that many times yourselves. I certainly have done it when somebody's constantly bombarding me with endless questionnaires. I'm just like, oh my God, let me be. All right. So this internal reliability is important to make sure that you don't get all strongly agree answers, because then it makes no sense. Somebody who says, I'm a person of worth, strongly agree, and I feel that I'm a failure, also strongly agree. That completely nullifies the results. And that's because of our human nature of trying to be cognitive misers. We don't like to do things. We like to be lazy. All right. So we have to be careful when we create our assessments or our scales. All right. Inter-rater reliability actually is very intuitively easy to understand. You have to have two raters. That's why it's called inter-rater. And these raters are observing the same behavior at the beginning simultaneously. And then we calculate whether they agree. So in the question that we discussed before of instances, number of instances of verbal or physical attacks on the playground among children, we can have two observers do that from different angles, perhaps, and then they would be doing that over a period of time, let's say for an hour, and then in an hour we have 12 5-minute intervals. So each of our observers will give us 12 numbers. So the first 5 minutes, observer number one saw 3 actions from Johnny, and observer number two saw 1. Well, that's close enough, right? And as we move through the remaining 11 pairs of numbers, we are looking for correlation. That is, as observers 1 scores go up, so do the observers 2 scores. And if they become like this, then inter-rater reliability is poor, meaning that either our operational definition of instances of verbal and physical attacks is not good, or we haven't trained our raters well enough. So again, we use this mathematical statistical apparatus of Cronbach's alpha and correlation coefficient R, which is described in the textbook, but you'll learn more about it in Sci 266 when you take that. For now, as long as you understand what it means to correlate, you are in business. You don't need to know a lot about actual details. Okay? Sometimes, and that happens, it's kind of hard to find good or high inter-rater reliability if your variable that you're trying to study is difficult to operationalize. Again, happens. Hopefully, it's not going to happen for your assignment number 2. Okay, so let's have a look at the question. So your car speedometer fluctuates between 15 and 30 miles per hour as you're driving on a freeway at a constant speed. As a measure of speed, your car speedometer is low in what? So we measured speed. It's a constant speed in the beginning of the hour, and it says 15 miles per hour. And at the end of the hour, we still are driving with the same speed. It says 90 miles per hour. So what is the problem with your speedometer? Rita, what do you think? What is the problem with the speedometer?
Professor, I'm sorry, I'm driving right now.
Okay, so you can answer. All right, good. Good, not so good. Jenny, can you type? Reliability, yes. Thank you, Jenny. You were ahead of me. Yes, this particular speedometer is problematic when it comes to reliability. Now, the next question is, which of the 3 types of reliability is involved? Who can answer this question? Jasmine, would you like to try? So is it test,
I'm
retest?
sorry, right now I'm learning by listening to others. I'm watching and learning. I don't know how to participate in this.
Okay, all right. Who else do we have? Jasmine can do it for us. Joanna, what about you? Luis? So is it test retest? Is it internal or is it inter-rater? Is everybody driving? Yes, Jenny, thank you. It's test retest, right? We are checking the reliability of our instrument, in this case pedometer, at 2 different points in time. It is test retest. Thank you. All right. Okay, so the technical way, like I said, is correlations and Cronbach's alpha. But there is an easy way to sort of visualize this, and that is through the scatter plots, right? Already we talked about scatter plots in chapter 2, so we're just coming back to that a little bit in more detail. So scatter plots are basically figures, right? Or graphs, charts if you want, that have 2 axes, the y-axis and the x-axis, and we usually plot our dependent variable, in this case our response variable, on the y-axis, and we plot our predictor variable on x-axis. And the scatter plots are kind of simple. So you're going to take your 2 observers that are observing children's behavior, right, on the playground. And we will use these 5-minute intervals for an hour. So we'll have 12 of them, 1 through 12. And that's where we will post, and the same for the y-axis, we will post the dots that will be what observer 1 and observer 2 found. So let's say 1 and 2. So we're going to have, well, I'm going to show you the scatter plots in a second. And we will see whether we have the direction of the scatter plot going up, it's a positive direction, or going down, that's a negative direction, or there's nothing, they don't correlate at all. Okay, and to do that, obviously it's very nice to see it in a figure, but we actually need to know whether this relationship is strong enough, and that's where we calculate our correlation coefficient R. It's a little r because there's also Pearson, just a little different. Okay, so what happens, we want to make sure that in, let's say we're testing our inter-rater reliability, we are looking at or some other reliability, we are looking at whether this relationship between the dots on a scatter plot is close to the line in the middle, which would, meaning that if it is 5 for observer 1 and 5 for observer 2, it's going to be on that line. 10 and 10 is going to be on that line. 15 and 15 is going to be on that line. But if the number are different, then the dots will be deviating from this line. So then we take these 2 sets of numbers. I'm just describing to you in a very simple way how correlation coefficient is calculated. And you're looking at using them in a statistical procedure that calculates the R. And this R is always, should be a little r by the way, this R is always between -1 and 1. So there are 2 components, and that was one of the questions on your quiz 2. We're not going to get to that today because it's more about validity. But the question is, you have to assess both components. You have to assess the strength of the relationship. And the strength is regardless of the sign. So +1 and -1 are exactly the same in terms of strength. +1 means it's perfect correlation that never exists in the real world. -1 means the same. It's also a perfect correlation. What's different is the direction. So +1 is as one variable goes up, so does the other. So it's the positive slope. -1 means as one variable goes up, the other one goes down. It's a negative correlation. But the strength is different from these numbers, from these signs. The strength is about a number. So anything between 0 and 0 and 0.2 is basically no correlation at all. 0.2 to about 0.4 is weak. 0.4 to about 0.6 is medium, and above 0.6 is strong correlation. So here, if we were to, let's say, look at height at the age of 18 and the height of a child at the age of 2, we will see a very strong positive correlation. The taller the child was at 2, the taller the young adult will be. Okay? But if we look at correlation between the height of a child at the age of 2 and his or her SAT score at the time when he or she graduates high school, is going to be nothing. Your height doesn't tell us anything about your scholastic aptitude. So this is how it is represented on a scale on these scatter plots. So here in one, let's get something, annotate. Good. And that was the color somewhere. Let's have red. So here, these dots, as you can see, whatever the amount of abdominal fat, whichever way we measure that, the line of perfect correlation, oops, why don't you do that? Oh, but now it went up. Let's go back. And to annotate. Right, this is not a very good line in my execution, but you can see that the dots fall on either side of the perfect correlation line, giving us an R of medium range. But here is the one where we are looking at the correlation between the child's height at the age of 2, as you can see, 50 inches versus 66, and that child's height when he or she's 18. And as you can see, this correlation is almost perfect. And that's the R value is almost 1. And remember, 1 is the upper bound. So it's a perfect correlation. There are very few exceptions unless, something happened to the child. And here is the one where we see the perfect, well, not perfect, but relatively strong negative correlation, right? If we were to put the line here, there will be a lot of dots that will be on sort of close to the line, but then there are a few outliers, like here and here, for example. So this correlation is almost strong, not quite, but the sign is negative because the slope is negative. And here the sign is positive because the slope is positive. And here is the relationship of which there is none. Your height at the age of 2 has nothing to do with your SAT scores. So somebody who was short could have a medium SAT score, and somebody who was also short could have a very high SAT score. So scatter plots are very important tools when you are looking at correlational designs, like association claims. Okay, let's get rid of all of this. No, clear, there we go, clear all drawings. Okay, good. So for these 3 types of reliability, we have different numbers. So for test retest, 0.5 and above is considered to be a good one, which means we are very stable in what we're getting. For inter-rater reliability, it has to be much higher. It has to be 0.7. And if it's below 0.7, you have to go back to the drawing board and change your operational definition or train your raters. And for the internal variability, we have the special Cronbach's alpha, which similar to R, but it takes into it's actual multiple R's. Really, that's what it is. Multiple R's for each question. And then we calculate the alpha that has to be 0.7. Again, you'll learn a lot about that, hopefully, in your 266 class. Okay, let's do a couple of questions and be done for today. So here is Dr. Valencia, who is considering conducting a study examining whether narcissistic people have poor social interaction than those who are not narcissistic. One of her first tasks is to determine which of your participants are. So she decides to use the scale created by a colleague, and it's called a Mayo scale. So question 1 says, I tend not to think about other people as much as of myself. Obviously, you are more narcissistic if you say yes. Question 2, I do not have a high opinion of myself, means you probably are not narcissistic. And question 3 is, I think other people think I am really special. Again, high narcissistic feature. So before using the measure in her study, Dr. Valencia gives the measure to a group of students on Tuesday. She gives the measure to them again on Thursday. Then she compares the scores between the 2 days. This is a test of which type of reliability? Okay, the person who answers this question will end the class. So there is an incentive to be fast and correct.
I believe Jenny and I wrote test and retest.
Test and retest, because it is 2 different time points. Absolutely. And very good, Siva and Jenny. And if you did not guess that, you would have had these multiple choice possibilities. So this is my advice for you. And before we finish the class, when you are doing multiple choice tests, either for this class or any other class, especially if you have time, the way to often answer them correctly is not to look at the answers, but try to answer it first based on what you remember or know from the text, and then look at the options that are provided to you. Once you said test, retest, you don't need to look at anything else. Because yes, it's not about internal reliability, because it's not about parts of the same test correlating with each other. And it's not construct reliability, because there's no such thing. There is a construct validity, but not construct reliability. So once you answer the question, it's much easier than to figure out what the actual option is for the multiple choice questions. Okay, guys. Thank you for being with me. Remember, if you write a 200-word summary with some questions, or maybe do something else related to these 2 options, that is variable scales and reliability, you can get your point for participation. Otherwise, the class is over. I'll see you guys on Thursday. You're welcome, Vanessa. You too, Kim.
See you Thursday. Thank you.
You're very welcome.
Thank you.
Take care,
All
Siva.
right, see ya. See ya.
Bye, Rita.
Hi,
Are you
Professor.
want to talk to me more, or you're just saying goodbye?
Yeah. No. For previous class, we didn't have the discussion board. I was looking for the discussion board, but the discussion
Right.
board wasn't open.
It's open now because I closed it because I wanted you to focus on assignment 1. So there was nothing for you to do. But now there is a bunch of things as of today until Monday.
Okay, so can I post for the previous class too?
If yes, you can. Yes, you can.
Yeah.
Mhm.
Okay.
Just
All right.
go to the right
so
forum.
I can post for that class.
Yes,
And
go to forum 5, and this is going to be forum 6 for this week
Okay.
until Monday.
All right.
Drive
Thank you,
safely.
Professor. Have a good night.
You too.
Thank you.
Yeah.
Bye.
Bye.